The future, the future of verification. The evolution of verification may have slowed down, but in the industry is hitting a tipping point that will drive some major changes. Can verification get ahead of the problem? Especially at these tables. Muandene, Dinesh Rao, Andy Nightingale, Anna Christmas, and Frank Schmeister. There is what part 1 and part 2. Let's see. What the new verification methodologies are needed to tackle the complexity problem with. If you gave us all a spec, we would all come up with a different design, different implementation. With deviations happens during the implementation. You design the spec, you buy those implementations, but how we verify them is going to be different. We may have different methodologies for archiving the same requirement, and therefore there are the different dimensions associated with how we might go about the verification. Automation is a missing piece. How do you approach it? You could approach it with AI. There are tools out there that use AI to come up with the test cases that you haven't thought of, but it's still probably not good enough. Schmeister, why hasn't the portable stimulus PSs taken over the world? Taken over the world. We introduced it more than 10 years ago, and yes, it used in some cases. There are distinct use cases where it applied, but it was exactly trying to do what the constraint random was to IP at a system level. Why hasn't it taken over the world? Then, if you look at the other tools like emulation, that's not new. It was 2 decades ago, but it started to be adopted for new applications very recently. Finally, if you got a place where you can run a certain workload, which was impossible to do in simulation, we can get to the inflection point, similar with the former solutions. Former solutions were there in the 90s. There was a small part of the work done by some teams, but former could not fully verify your instruction at the architecture level or do domain-specific architectures. The former tools became a necessity. Similarly, for a portable stimulus, you get a critical mass where you want to love to shift. There's when you really hit that inflection point where you should feel the SVUVM is not the solution you are looking for. You realize that with the SVUVM solutions, you cannot do SOC verification. The only way you can verify that this is with a portable stimulus. But as long as the people have an option they are happy with, and that can be used to tape out a chip, they will tend to stick to that path. Schmeister. Emulation was already there, but the growth has continued. It flattened a little bit around 2020, but now it's really AI and data centers, because you really need to verify the workload. Perhaps there was a point where a portable stimulus can generate more data for it, more of the verification payload, where we might see a regeneracy of the simulation, a similar technology. You bring up a good point about portable stimulus. There is a paradigm shift that needed, where if you build and verify paths of the IP enough that's gonna be reused, it shouldn't be seen as verified unless it had some third-party VIP on it. This is where we'll come with the chiplet. ARM is bringing out the chip-to-chip specification, but we should not believe the specification is fully verified by them. They needed external verifiers, so that is a paradigm shift. They need guys from the Synopsys and other ED companies to come along and say, this is our interpretation of your specification. This is how we think it should work. Schurmeister. On top of that, you have the chipset architect, you have CSS by itself, and you have CSA, which define the threshold chip component, and so forth. Can I rely on that AI accelerator to do that for me, who is just accessing the memory? That adds another layer of complexity. Nightingale. An exchange of the VIP is necessary. We need to go from a single provider philosophies to picking a verification partner for future IP. Now you verify with the implementation of the interfaces, and then we can have more confidence because our implementation gets tested. Your interpreting gets tested, and we actually find issues where we thought bit sentence in the spec actually means different things to different people. Schurmeister. The cynic in me then looks back at things like race conditions in simulators. We can't even agree on how to implement the simulator because it's a way the language reference manuals are written, even those are not completed. Is there an optimism that a verification will get better in the future? Is that because of AI? Alan, it's because of AI. I've been wishing for years that the data cycles on the CPUs in my machine could do some work for me between keystrokes. It's as simple as chat. Computers are faster than our brain. We are talking about where we can change the level of symbolic architecture. PSS, for example, or granularity of Lego bricks 3D IC. But if we can just get brute force machinery to do the hard work for us, then we can verify anything. This is where AI comes into picture. In terms of independence, the software guys solved this decades ago by introducing extreme programming or pair program. You work alongside one real good human brain or perhaps two AI agents, each programmed differently, each with an orthogonal set of thinking, helping an expert designer get it right the first time, get it correct by the design first time. That's an example of how we might use agentic AI to be part of our solution in the future. This is what we are working on. We are working on the piece of this, and we have a vision for how it might come about. Schurmeister, but it's not only AI. AI is one half of things. We are doing these things where tests are seen being generated without AI. AI helps to get us into more cases, but it's not only AI. AI is just another algorithm. I would say it in three different ways. One is AI contribution to whole ecosystem or infrastructure. We need to have earlier verification. Design and verification have been separated by the agentic AI, and they are going to tightly coupled. We are going to see a significant reduction in terms of black box verification, where you verify without knowledge of the design implementation. We'll be moving forward toward a high box verification, especially with the various silicon agent working alongside a formal agent, simulation agent, working in harmony with the human in the center. This is that's going to make a significant impact beyond what an expert can do at this point. That is in terms of a whole ecosystem. AI is contributing significantly point tools as well. AI in simulation, AI in formal-like simulation. Now you can get to the same coverage with the fewer tests so that you can significantly increase the throughput. So the individual point of tools are doing well because of AI. Lastly, in terms of a DB engineer and designer engineer, the days of handwritten unit test cases are numbered, so even from the perspective, AI is making the significant progress. Schurmeister. That's what I meant by test automation, but then you said something very important. The user remains in the center. AI is not replacing the people. I'm not worried. If I am a verification engineer about my job being replaced by AI, I'm worried about my job is being replaced by another person who knows how to use AI. Then AI is not replacing jobs. It is changing the role of the people. There are certain roles that don't need to be there because of AI, but people are still needed. Usually the problem of the orchestration. Now you have this orchestration task. It's getting better. It is a workflow transformation. As part of the workflow transformation, you're now in an immersive environment. Instead of driving a tool, we are looking at a task-driven tools, and then you are left shifting some of the verification. If you have enough agent working for you as you are designing, some of these things are going to be get flagged without having to run a lot of backend verification. You already have verification, it's absolutely needed, but it is left to shift something. At what point do the survey agree that we have turned the corner and we are now ahead of the problem? We are first to have to do what first pass success means. I wish we had a database of all the things that cause the spin, because you can look at the correlation. If see if there are certain use cases and exactly which use cases are driving the problem. Then some companies are much better than others in terms of first pass silicon. That data is quite interesting to look at. We see the companies that have adapted the latest tools and methodology, which can adapt themselves quickly to these rapid changes. Those have done quite well. Germeister functional issues are stable in terms of number of the spin they cause, but there is an increasing array of other issues that are causing respins. The figure said that 15% of the designs do not have any of these issues. I don't question the data. We just need to dig into more. What do you think is the most important change we are going to insert verification in the next year or two? AI is a mutuation capability to get into those corner cases, and then the aggregation of the marginal gain from all technologies being developed. They are each adding together, and that would help the curve over time. Schumeister, agentic AI verification for the last 25 or 30 years, we have not been able to get ahead of verification in front of design. Unfortunately, even though the becoming advanced, I don't see any reason why it will. Agentic AI is given bring together software and artificial design and verification. We separated them decades ago. We are bringing them get back together now with the software aware verification, because software is a critical component. Agentic AI, but also expansion to the system level. Doing a chip by the chip itself may be that for more straightforward. Everything gets locked up when you are doing a higher level integrations and more packaging the unknowns and multiple physics. Then agentic AI is driving more toward the white box verification will be a game changer. From a chiplet perspective, we definitely need to capture more knowledge, which will be the form of the simulation models. They are required to do the multi-chiplet simulation. We also need something that is power aware. I read the article, The Future of Verification. Thank you for your time. See you next time.